Um, in this video, I am going to discuss one of the applications of the definite integral. And this is about the centroid of a plane area. Now, to determine the centroid of a plane area, we must find two averages x bar, which is the average value for the abscissas of the endpoints, um, number of elements, and y bar, the average value for the ordinates or the y coordinate of the endpoints of the number of elements. Okay. Suppose we have this plane area. Okay. You have this curve y a function of x and then bounded by also the x-axis and this line x equal to a. Now, using Riemann summation, we can approximate the area by considering um, several rectangles like this up to the um, upper limit. Uh, Now, if you use integration, the exact area is this one. So, to determine the centroid, we will use the first moment of area, similar to Varignon's theorem about forces. So, the first moment of area about an axis equals the sum over all the infinitesimal parts of the shape of the area of that part times its distance from the axis. Okay, so inan ang first moment of area. Uh, ang moment sa individual elements about a certain axis like y or x is equal to the moment of the whole area. Okay? From the centroid to the y or the x-axis, like this one. So for each rectangle, you locate the centroid like this one, up to the last rectangle. Okay? And then get the moment. No? So if we get the moment about y, moment of area about y, we need the horizontal distance from the centroid of each element to the y-axis, like this one, up to the last centroid. Okay? Now, if we add ni tanan, if you get the algebraic sum of this, you will have this. Moment about y is the sum of a sub I times x sub I from 1 to n being the last rectangular element. Okay. Now, the algebraic sum is equal to the moment of this whole area. So first, you locate the centroid of the whole area, this one, and then you get the distance of the centroid to the y-axis, and that is our x bar. Okay. So the algebraic sum of these individual moments, this one, is equal to the moment of this area times this distance x bar. And it's the same. Okay. So Moachag Varignon's theorem applied to area. Mag-analogy siya sa Varignon's theorem. So to solve for x bar, we have this. Summation of I from 1 to n divided by area total. That is our x bar. You do the same for y bar. So we sum up moment about the x-axis and we get the y distances of all the centroids of different elements. Get the y distance like this up to the last rectangular element. So you get the algebraic sum of these moments about x. You have this summation of ai, yi, I from 1 to n and it's equal to the moment of this area at the centroid. So from the centroid, you get the distance to the x-axis. That's our y bar. So this one is equal to area total times y bar. And to solve for y bar, now we have this. Um, so this is our formula using, if you use Riemann summation, where we consider rectangle. No? But when we use integration, we will only consider one rectangular strip, and then we just integrate or we sum up from lower to upper limit. So this is how are we going to uh, analyze or determine the center of a plane area using integration. So instead of considering several rectangles or using Riemann summation, we'll just consider one rectangle and then we use integration. We integrate this one or sum up. We have this. Suppose we have two curves and this is the bounded region. Di ba? So we have two options. Either we analyze a vertical strip or a horizontal strip. Suppose we analyze a vertical strip. Okay? So first, i-label na to. X up, Y up, and then this one, X down, Y down. And then we get the height of the strip, which is Y up minus Y down. Okay. And this has been discussed sa plane area. So this is Y up minus Y down. Now, our formula for centroid using integration is this one and this one. Now take note na this is similar sa Riemann. Sa Riemann summation, instead na we use the summation, sigma notation, we use the integral side, integral niya, differential area, dA, considering only one rectangular element. So, interchange lang eh. Transfer sa left side and this one sa right side. But in this case, instead of simply putting x and y, I put a subscript EL, which refers to element, this one, rectangular element. Okay. So, what we will do is to determine x sub EL and y sub EL. So, how do we determine these values? For dA, it's very simple. We have discussed this one. This was discussed already sa topic on plane area. Okay. So, for this topic, okay, our focus is on x sub EL and y sub EL. Now, these points, x sub EL and y sub EL, are the coordinates of the centroid of the element. Okay? Like this one. This is the centroid. Okay? Centroid for this element. So, what are the coordinates of this point? Okay? So, okay, this one. This is x sub EL. What's the value of this? As you notice a graph, x down and y down, x down and x up are equal. Diba? Because if you plot these 2 points from the origin, that's x down, y down. And then for this one, the upper point, x up, y up. So x down is equal to x up. X sub VL is also equal to x down or x up. Or we can just put x without any subscript because the three points are the same. X down, x up, x sub VL simply equal to x. Okay. But for y sub EL, this is y sub EL. Okay. Y sub EL is the average of y up and y down. Bali, midpoint siya sa upper o lower na point. Okay. Like for example, if this is 5 and this is 9, then in between is 7. Diba? 5 and 9, 7. So how do we get 7? It's simply we add 9 and 5 and then divide it by 2. Or y up plus y down over 2. That will be our y sub EL. Now, if we will analyze a horizontal strip, okay, like this one, so our label will be x left, y left, and x right, y right. And the length of our strip is x right minus x left. Now, this is the centroid of our element. And from this point to the y-axis will be our x sub EL. Now, for this one, our x sub EL is the average. Oh, average, yeah, bali. If the x coordinate of this point is 2 and the x coordinate of this point is 6, then in between 2 and 6, you have 4. So how do we get 4? It's simply x plus 2, 6 plus 2, 8 over 2, 4. Yeah. That will be our x sub EL, average. While for y sub EL, it's simply y because from the graph, we can see that y sub L and y sub R are the same as well as y sub EL. So our y sub EL is simply equal to y. So you try to remember this. Now, when you analyze a vertical strip, y sub EL is the average. X sub EL is simply x. But if you will analyze a horizontal strip, ang x sad ang average. Ang y sub EL is simply y. Okay. So let us solve some problems to better understand this one. First problem. Find the centroid of the region with the indicated boundaries. Y equal to x cubed and y equal to 4x in the first quadrant. Okay, so first, i-plot ang curves. So, first, you have y equal to x cubed. So, when you want to plot this one, you can just substitute any value of x and then for every value of x, get the value of y and then connect those points and you can plot the graph. So, this is the graph of y equal to x cubed. Okay? It passes to the origin. And for the line y equal to 4x, it will also pass to the origin and with a positive slope. This one. Okay. So this is the bounded region. So our objective here is to find the centroid of this region. First is we analyze this one strip. You can use a horizontal strip or a vertical strip. Okay. So I will be using a vertical strip and you can use a horizontal strip to check the solution. Okay. So label na x up, y up, and then x down, y down. And we have our thickness dx, height of strip na y up minus y down. Okay. So first we solve for the area. Okay. Kailangan tayo area total. And we also have dA. So from our strip, our area is y up minus y down times dx. This one. Y up minus y down times dx. So we integrate para makuha ang total area and we need the limits, lower and upper limits. So we need the coordinates of this point. So we need the point of intersection. So we equate y equal to y. Pinaka-simple. Y equal to y. And we have x cubed equal to 4x. And then transpose. And then factor out x. and then separate x equal to 0 and the other one x squared minus 4 equal to 0. So transpose 4. Okay, you have x equal to 2. Supposed to be x is equal to plus and minus 2. Square root of 4, that's plus and minus 2. Because you have a third point with intersections, a third quadrant. X equal to negative 2 and y equal to negative 8. But since ang problem is only considering the first quadrant, so we'll just consider x equal to 2. So for this point, when x is equal to 2, y is equal to 8. Okay. So, since dx ang limit na to is x from 0 to 2. Okay. And then we substitute y up and y down. Y up na to is line, kaning red. And our y down is kining cubic equation, blue. Okay. We have this. From 0 to 2, y up straight line minus y down, x cubed. And then using power rule, we have this. And then evaluate from lower to upper limit. The area is equal to 4. So after this, we locate the centroid. Okay, so this is for x bar. Okay, now, okay. X sub L, again, we are considering a vertical strip. So from what I have discussed earlier, for a vertical strip, x sub EL is simply equal to x. So this is our centroid, and this is our x sub EL, or simply x. So we replace this one by x, and then dA replaced by this, or simply this one. Y up minus y down replaced by 4x and x cubed. Uh, our area total is 4. Our x sub EL is x, and then this is dA. So you distribute x, and then using power rule, this is the result, and then you evaluate from lower to upper limit. The answer is 64 over 15. No? 4 thirds times 2 cube 8 minus 2 raised to 5 over 5. The result is 64 over 15. And divided by 4, x bar is 16 over 15. And then after this, you have y bar. So y bar, we have this. Our y sub EL, again, this one. For a vertical strip, y sub EL is average. This one. Y up plus y down over 2. So, mao ni ang result. Y up plus y down over 2. And then our dA, area sa strip, area sa rectangular strip, y up minus y down over 2. So, when you multiply, the result is difference of two squares. This is the result. And then you replace y up by 4x, bali line, and then you replace y down by x cubed. Okay. So y up is 4x, so you square 4x, you have 16x squared. And our y down is x cubed, you square that, that's x raised to 6. And then integrate using power rule. And then you evaluate from lower to upper limit. This one. And then compute this one, equate sa left side, and you have this. And then divided by 4, y bar is 64 over 21. Okay. Another one. Find the centroid of the region with the indicated boundaries. Y equal to x squared minus 4 and y equal to 2x minus x squared. Okay. So first is we transform these equations to standard form so that we'll be able to locate the vertex, and at the same time, we will know where the parabola opens. The standard equation of a parabola is this. For x squared, for x squared. If positive, then opening upward. If negative, opening downward. So for curve 1, this one, y equal to x squared minus 4. Okay. Let's transpose x squared sa left, or we rearrange terms and we have this x squared equal to y plus 4. So kung i-fit nato ni siya sa standard form, and we have this x minus 0 squared and then parenthesis y plus 4. And since ang default is negative, then our vertex is 0 and negative 4. Okay, dapat y minus negative 4 na siya para positive 4. And since positive siya, dire, and then the parabola is opening upward. Okay, basta inaan ang standard form, upward, downward man eh. Okay? 1y, 2x, pag x squared. Okay. Upward, downward. For curve number 2, this one, okay, so we transpose x squared. And then, we complete the square because the left side is a perfect square. So for the left side, we need a constant term, this one. So we need a third term para mahimo sa perfect square. And whatever numbers added sa left, you add the same numbers sa right para balance lang. So for the constant term, what we will do is divide this one, the coefficient of the first degree term, divide by 2. So 2 over 2 is 1. Square na 1. Right? So sa right side, mag-add siya kag 1. So ang result, the left side is already a perfect square. And then negative will be extracted sa y para nata parenthesis. The result is this. And so the vertex is at 1, 1. Kaya negative man sila duha. Default negative. So vertex at 1, 1. And then since negative, ang sa right, then it's opening downward. So kung i-plot na to ang vertices, we have this 0, negative 4, dire. And the other one is at 1, 1 here. Okay. So to have an accurate drawing, let us first determine the points of intersection. So points of intersection, we equate the two curves. So the simple one is y equal to y. Okay, x squared minus 4 equals to x minus x squared. Rearrange. And then divided by 2, you have this. And then factor out. Factor na to x minus 2, x plus 1. And x minus 2 equal to 0 and x plus 1 equal to 0. X equal to 2, x equal to negative 1. So when x is equal to 2, is substitute. When x is 2, 2. Y is 0. Okay. And when x is negative 1, y is negative 3. So i-plot na to. 2, 0 is here. And negative 1, negative 3 here. Somewhere. Okay, so we have opening upward, vertex at 0, 4, and passes to these 2 points. We have this one. Opening upward, and then The second curve, vertex at 1, 1, open downward. Mga gisad sa red na points. So, this is the first curve and the second curve. Okay. This is the boundary region. Okay, so first we solve for the area. So we analyze a rectangular strip. To avoid a split, let's analyze a vertical strip. Para di tayo mag-split. So, x up, x down, y down, dx. So we solve for the area, y up minus y down, as usual, y up minus y down dx. Okay, our y up is ang red, 2x minus x squared. Our down is ang blue, which is x squared minus 4. And then combine like terms, negative x squared, this one. And then use power rule. And then evaluate from lower limit to upper limit. And the area is equal to 9. Okay. So next is ang location sa centroid. Okay. X bar. Again, pag vertical strip, x sub EL is simply equal to x. Now, this one is sa previous na step ba? This one. The simplified one. 2x minus 2x squared plus 4. Or this one. Pag simplify, this one. So, we distribute and then use power rule and then evaluate from lower to upper limit and then simplify, equate sa left side, and we have x bar equal to 1/2. Next is for y bar. And for a vertical strip, y sub EL is average. Y up plus y down over 2. This one. And you multiply, the result will be difference of two squares. Okay, this one. We put 1/2 before the integral and then ang resultant is this one. Y up squared minus y down squared. Okay. So this is y up squared minus y down squared. You expand, we expand this one and also the second term. This is the result. You just square of this and then multiply the two terms and then times 2, this one, and then square this one. Same also with this square x raised to 4. Multiply the two terms, negative 4x squared times 2, you have negative 8x squared. Square of negative 4 is positive 16. And then you combine similar terms, x raised to 4 will be cancelled. And so we have this one. And then power rule. And then evaluate from lower limit to upper limit. And then equate. Then y bar is negative 3/2. Okay. So for this topic, your guide is this one, no? That for a vertical strip, x sub EL is simply x and y sub EL is average y up and y down. And if ever you will encounter a problem wherein you will consider a horizontal strip, then ang x sa BL niya is average at x right plus x left over 2. Whereas ang y sa BL is simply y. Okay. So, I hope that you have learned something from this presentation. Thank you for watching.